Today's lesson is about Introduction to Arithmetic Sequence. A ceramic tile floor is designed in the shape of a trapezoid, 10 feet wide at the base and 20 feet wide at the top. The tiles, 12 inches by 12 inches, are to be placed so that each successive row contains one more tile than the preceding row. How many tiles in the sixth row? We know this is the first row, second, and a third, fourth, and so on. We use n equals 1 to stand for the first row, n equals 2 to stand for the second row, n equals 3 for third row, n equals 4 for the fourth row, and so on. The number of tiles for the first row, we will use U sub 1 to represent. So U sub 1 equals 10. There are 10 tiles in the first row. Since each successive row contains one more tile than the preceding row, the number of tiles in the second row equals 10 plus 1 equals 11. The tiles in the third row, U sub 3 equals 10 plus 1 plus 1. We will write down 10 plus 2 times 1. U sub 4 for the number of tiles in the fourth row equals 10 plus U sub 3 plus 1 will be 10 plus 3 times 1, and so on. We are looking for how many tiles in the sixth row. We use U sub 6 equals. Look at the pattern. For U sub 1 equals 10. U sub 2 equals 10 plus 1. U sub 3 equals 10 plus 2 times 1. U sub 4 equals 10 plus 3 times 1. For this one, we can write down 1 times 1. Let's check the relationship between this number and this number. 3, this is a 2. 4, this is a 3. So we can figure out U sub 6 equals 10 plus. This will be 5 times 1 equals 15. For B, how many tiles in the 10th row? U sub 10 equals 10 plus 9 times 1 equals 19. For C, how many tiles in the nth row? This time we will use U sub n equals 10 plus n minus 1 times 1. We will do distributive property 10 plus n minus 1 equals 9 plus n. Let's go to D. If each successive row contains D more tiles than the preceding row, how many tiles in the second row, third row, sixth row, 10th row, and nth row? The first row, we use n equals 1. The number of tiles in the first row, I use U sub 1 equals 10. The second row, n equals 2. We know the U sub 2 equals D more tiles than the preceding row, 10 plus D. Then for the third row, U sub 3, number of tiles equals 10 plus D plus D, which means 10 plus 2 times D. In the fourth row, U sub 4 equals 10 plus 2D, then plus D. That equals 10 plus 3D. We can check the pattern. This is a 4. We will get 10 plus 3D. This is a 3, 10 plus 2D. This is a 2, 10 plus 1D. According to this pattern, we can figure out in the sixth row, number of tiles will be 10 plus 5D. 10th row will be U sub 10 equals 10 plus 9D. In the nth row, U sub n equals 10 plus n minus 1D. Let's go to E. If there are U sub 1 tiles at the base, it's not a 10, it's a U sub 1 tiles. Each successive row contains D more tiles than the preceding row. How many tiles in the second row, third row, sixth row, 10th row, and nth row? In the first row, we use n equals 1. U sub 1 is used to stand for the number of tiles. In the second row, U sub 2 equals U sub 1 plus D, because each successive row contains D more tiles than the preceding row. In the third row, number of tiles U sub 3 equals U sub 1 plus D, then plus D, equals U sub 1 plus 2D. In the fourth row, number of tiles equals U sub 1 plus 2D. This is for U sub 3 plus D equals U sub 1 plus 3D. Now we can figure out the pattern. For U sub 6 equals U sub 1 plus, this is a 6, it will be 5D. U sub 10 equals U sub 1 plus 9D. U sub n equals U sub 1 plus n minus 1 times D. This is the formula for arithmetic sequence. We also call it the general form of arithmetic sequence. Now let's talk about the arithmetic sequence notation. Here's the definition for arithmetic sequence. The sequence where the difference between one term and the next is a constant is an arithmetic sequence. For the notation, U sub 1 is the first term. This n means ordinal number. In this type problem, n equals 1 means the first row, n equals 2 means the second row, and so on. This D basically is the constant. we call this is a common difference. Any term minus the previous term will be the common difference. U sub n, we call this is a nth term. According to this nth term, U sub n minus 1, we call this is a previous term. U sub n plus 1 is the next term. The formula for nth term is U sub n equals U sub 1 plus n minus 1d. In other words, we can write down U sub 3 equals U sub 1 plus 2d. U sub 70 equals U sub 1 plus 69d. U sub 100 equals U sub 1 plus 99d. For common difference, nth term minus the previous term. So this d could be U sub 10 minus U sub 9. It could be U sub 21 minus U sub 20. As long as you use the term minus the previous term, that will be a common difference for arithmetic sequence. Let me talk about the difference between arithmetic sequence and a linear function. For U sub n equals 2n plus 1, this n is a natural number, which means this n started from 1, 2, 3, and so on. For linear function, f of x equals 2x plus 1, x is all real numbers. Then look at the graph. When n equals 1, 2 times 1 plus 1 will be 3. N equals 2 is 5. N equals 3, it will be 7. N equals 4 is 9, and so on. So you could say for arithmetic sequence, the graph is the dots. For linear function, since x is all real numbers, when x equals 0, y equals 1. When x equals 1, y equals 3. X equals -1, y equals -1. So for linear function, the graph is a straight line. For the range of arithmetic sequence, 3, 5, 7, 9, and so on. For linear function, the range y is all real numbers. For linear function, this 2 we call is a slope. For arithmetic sequence, this 2 is a common difference.